Hey everybody, Mrs. KJ here, going over part 2 of 4.01 Monatomic Ions. Alright, so I added my webcam because some of this is just easier to see if we do a visual. And so we are going to actually back up one slide. There we go. Alright, so how many valence electrons does an atom want for a full outer shell? It wants 8. It can achieve that by, let's say it already has 7. Well, it gains one more and gets 8. No big deal. Or like we showed with sodium, it had that 1 valence electron, and what happened when sodium got rid of that 1? Well, it also lost that outermost orbital, right? Because there were no electrons in it, so we don't draw it anymore. So here on the screen, you can see it has 3 orbitals. When it loses that 1 electron, it's down to 2 orbitals. So the goal is either to get to 8 or to drop down to 0, get rid of that outer orbital, and now you have a new outermost orbital. So that's the idea. Now, atoms, like everything, including us, are lazy. Okay, they want to conserve energy, which is just a nicer way to say that they're lazy. So we look at group 1. Group 1 has how many valence electrons? 1. So is it easier to lose 1 or to look around and try and find 7 more to gain? Well, 1's less than 7. It's a lot easier to lose 1. So it loses 1 electron, and what would the charge be? Positive 1. Because it has 1 more proton than electron. All right, group 2 with beryllium has how many valence electrons? 2. So what is it going to do? Is it going to lose 2 or gain 6? Well, it's a lot less work to lose 2. It's going to lose 2 electrons. Woohoo! Okay, lose those negative electrons. What's the charge? Plus 2. All right, look at group 3, like aluminum. How many valence electrons? Group 3 has 3 valence electrons. What is it going to do? Lose 3 or gain 5? Well, it's going to lose 3. What's the charge going to be? Positive 3. Let's look at carbon. Carbon has 4. So is it going to lose 4 or gain 4? Well, it's a horse apiece, right? There's really no logic to what it should do. So in fact, it's going to share. Okay, so carbon and its group are going to share. The rest of them we're talking about now are gaining and losing, but carbon's group is always going to share. Aww, because it's right in the middle. All right, nitrogen. Group 5A has how many valence electrons? 5. So what is it going to do? Is it going to find 3 electrons, or is it going to lose all 5? Now remember, it's not like losing. It actually has to find someone to take them all. So what's less work? Gaining 3 is less work than trying to find 5 other atoms who want to take the electrons. So it's going to gain 3. Electrons are negative. Aww. So if you get 3 more, how do you feel? Negative 3. All right, now obviously there's not emotions, but if you think of the emotions, sometimes it makes it a little easier to remember. All right, oxygen. Group 6A has how many valence electrons? 6. What is it going to do to get a full outer shell and be stable? It's going to gain 2 electrons, and therefore the charge will be -2. All right. Next, we have fluorine. Fluorine is in group 7. How many valence electrons is it going to gain or lose? It's going to gain 1 to get a full outer shell and be stable. And since it gained 1 electron, what will the charge be? -1. All right, what about group 8? Let's ignore helium because that one's so tiny. It just has 2 electrons in its 1 orbital. Let's look at neon. Neon has 8 valence electrons. What is it going to do? Nothing. It has a full outer shell. It's stable. That's why it's called the noble gases, right? They don't deal with you little peasant elements over there because it is rich. It is noble. Like, in social studies class, the nobles and the peasants, okay? So it already has a full outer shell. It is not going to react with anything. All right, so let's go ahead and I want to skip that slide, and we will go ahead and look at the fluorine. Okay, I don't know if you can move the camera, so I'm just trying to move it out of the way. I also don't know how to make the camera disappear in the middle of a recording, so you're stuck. You can predict the charges on most non-metal monatomic ions by the group number and the octet rule. So let's make sure we understand all the words in that sentence. So charges, we want to know if it's positive or negative, and positive or negative, how many. That's super important. Nonmetals. Oh yeah, our nonmetals are over here on the right, except for which one? Hydrogen, which is way over here on the left, because why? It only has one valence electron. So all right, so over here in the middle and over on the left-hand side are the metals, and over here on the right-hand side, if I said left before, I'm sorry, right-hand side are the nonmetals. And what about this jagged line here, the stair step? Those are the metalloids, which are kind of like metals, kind of like nonmetals. All right, so we can protect the charges of our nonmetals by the group number, okay, by the fact that this is 6A and 7A. And the octet rule, meaning octet means 8, so how many electrons it needs to gain to get a full outer shell. A simple rule for predicting the charge of nonmetallic anions, what's an anion? A negative ion, is that the anion's charge is equal to the group number of the element minus 8. All right, this is one way to think of it. I'm going to tell you a different way when we're done with this example. For example, the halogen elements, group 7A, take up 1 electron to form an anion with a charge of minus 1. That follows the rule just mentioned. So 7 minus 8 equals negative 1. Noble gases, so helium, neon, argon, krypton, have stable electron configurations. They already have a what? A full outer shell, so they do not form ions because they're already stable. So again, if you're looking at the periodic table that I gave you guys, what I like to do is I just say, okay, 5 electrons, 3 more gives us a total of 8. So 3 and 5 is 8, 2 and 6 is 8, 1 and 7 is 8. But then you have to remember that it's negative because you gained them. So if you prefer this method, the subtracting the 8, whatever method works better for you. All right, so we talked about our cations, we talked about our anions, our noble gases, and let's go back to these messy middle transition metals. Monatomic ions formed by transition metals are not so easy to predict. The transition metals form cations too, but it's not as easy to predict how many electrons an atom of one of these elements will lose. Also, most transition metals can form more than one kind of ion. For example, the metals in group 11B, copper, silver, gold, all right, so right here, commonly form cations with a +1 charge by losing 1 electron, but copper often loses 2 electrons to form a cation with a +2 charge. So I like to call them the messy middle transition metals can have multiple charges. So for example, copper can be +1 or +2. Some of these can be +7, all right? So don't worry about that for now. Just know that, okay, they're messy, they don't follow our rules, but group 1A has a charge of +1 because it has how many valence electrons? 1. Group 2 has how many valence electrons? 2. Group 3 has how many valence electrons? 3. Okay, so using your group A's will help you out for this. And yes, that's my cat spot. All right. Hydrogen is an exception to these rules. The element hydrogen is a special case in ion formation. Hydrogen is frequently shown forming a monatomic hydrogen cation of hydrogen +1, which is what you'd expect because it's in group 1. But remember that a hydrogen atom only has 1 electron. If the hydrogen atom loses that electron, all that's left over is a single proton. Protons don't just hang around by themselves in the midst of atoms. A hydrogen cation is not found by itself, but in nature associates tightly with other atoms. In other words, it's going to bond to something. You should be aware that hydrogen plus is often written to represent a hydrogen cation. Accounting for it in this way in chemical reactions, though, is convenient but not completely realistic. Hydrogen is also unusual because it can form an anion with a -1 charge. So hydrogen can lose this and then just be a proton, and it's going to attach to something. So then it'd be hydrogen +1. Just like lithium in the same group, lithium's +1, sodium's +1, potassium's +1. So far, yeah, that's what you expected. But hydrogen can also gain another electron, because what's true about its orbital if it gains 1 more electron? It has a full outer shell, because only 2 fit in that first orbital and it's stable. So hydrogen is also unusual because it can form an anion with a -1 charge, which is called an hydride, ion. A hydride ion is very reactive because hydrogen is like the halogens in forming an anion with a -1 charge. It's sometimes placed on top of group 7 on the periodic table along with the group containing halogens. Okay, I have never seen that where the hydrogen's over here, except if they're trying to prove some kind of point. So don't worry about that really. This is kind of one of those, yeah, hydrogen, remember it's a nonmetal, so it's going to have some exceptions. But for the most part, for at least starting, we're going to say it's going to have a +1 charge. All right. Monatomic ion. So what's a monatomic ion? One atom, and it has a charge. Monatomic ions are formed from single atoms. Single atoms gain or lose valence electrons to form monatomic ions. Cations are positively charged, and anions, a negative ion, are negatively charged. All right, so cations, another way to remember that is the fact that cats have paws, right, Spotsies? You got your paws here that you're not going to show us? Yeah, so cats have paws, and it's positive. Like if you say it in like a really bad Boston accent, it would be positive. So it's another silly way to remember it. Metals, groups 1A, 2A, and 3A are in the periodic table, usually form cations with a charge equal to the group number of the element. They say usually, but really, I mean, for everything we're going to do, they do. However, transition metals, messy, middle, transition metals can have multiple charges and are difficult to predict. So we'll get to that in an upcoming lesson. Nonmetals, groups 5A, 6A, 7A, form anions with a charge that is equal to the group number of the element minus 8. Or in other words, it has how many valence electrons if it's in group 5A? 5 valence electrons. It's going to gain how many electrons? -3. It has those extra negative awful electrons. So what's the charge? -3. Group 6 has how many valence electrons? 6. What is it going to do for a full outer shell? Gain 2. So the charge will be -2. Group 7 has how many valence electrons? 7. What is it going to do for a full outer shell? Gain 1 electron. So what's the charge? -1. This is super important. This is like you've got to know if they're gaining or losing, how many, what the charge is going to be. All right. Noble gases do not form ions easily. Why not? Because they already have a full outer shell. They are already stable. So ions can be cations with a positive charge or anions with a negative charge, and they are predicted using the periodic table. Again, I don't care if you use a different periodic table, but make sure you write on it all this stuff that I have here on the cheat sheet. Okay, I wrote that down for a reason, for you, okay? All right, as always, if you have questions, let me know. Otherwise, that's it for the recordings for this lesson.